we talked about a quadratic function written in two different ways, and all we focused on yesterday, though, was which function? Which
Oh, the vertex.
the vertex form, which is also in some textbooks called standard form. Okay, so remember vertex form, and I'll give you vertex form. Here's vertex form. It says y equals a times x minus h squared plus k, where the vertex is what? Good, hk. All right, and the axis of symmetry is what?
Oh, yeah.
X equal, yeah, what is it though? What is it? H, x equal h. That's your axis of symmetry. Okay, so yesterday then we had this example. We said f of x equal, and I'm making this up, 2 times x minus 1 squared, let's say minus 8. All right, so 2 times x minus 1 squared minus 8. And there were a bunch of things that we found for that quadratic function. First of all, the vertex. What's the vertex? 1, negative 8. Because remember, it's got to be in the form x minus h. So if this was x plus 1, you would say, what is the vertex? Negative 1, negative 8. All right, so the vertex is 1, negative 8. Once you find the vertex, you can determine the axis of symmetry. The axis of symmetry x equal 1. Don't just say 1, you got to say x equal 1, because the axis of symmetry is a vertical line. Now, the axis of symmetry is not really part of the graph, because when you look at all parabolas, it's just a parabolic shape. You don't see that dotted line. I'm asking you to draw it to help you draw the parabola, because it's got to be symmetrical. Okay? Now, does this parabola open up or open down?
Up.
Why does it open up?
Because it's a positive number for A.
Because A is what number here? 2, and it's positive. So it opens up. All right, since A is equal to 2, which is positive. So then I'm going to ask you this. Well, what's the domain?
Negative infinity.
Okay. All right, now the range. Do you need to graph this function in order to tell me what the range is?
No.
No. All you got to do is in your mind kind of visualize what it looks like. So you know that the vertex is what point?
1, negative 8.
1, negative 8, right? 1, negative 8. So in your mind you have this. You have the point 1, negative 8, correct? Just put something like that. And you know that the parabola does what? Opens up. And whenever you talk about range, you always go from bottom up along the y-axis. So when I go from bottom up, even though it's not drawn here, those axes aren't drawn, it doesn't matter. It's going from negative 8 all the way to what? Infinity. With a bracket. Okay? All right. Is this vertex a relative max or relative min? Relative min. And again, it's always a good idea to, right on the side, just do what I just did. Just draw a rough sketch of it with just the vertex. So you know that that's a minimum, right? So it's a relative minimum. Now, the y-intercept. Remember, the domain is what?
Infinity to
Negative and infinity. What x value is in that domain?
0.
0. So whenever you let x be 0, you are finding the y-intercept. You're finding the y-intercept. Let me ask you this before we go on. And we talked about this yesterday. Do all quadratic functions have a y-intercept?
Yes.
Yes. Because what's the domain?
Negative infinity to
Negative and infinity. And what number is in that domain?
0.
0. So x equals 0. Whenever you let x equal 0, you're finding y-intercept. But will all quadratic functions have x-intercepts? No, we saw that yesterday. If your vertex is above the x-axis and it goes up, will it cross the x-axis? No. If your vertex is below the x-axis and it goes down, will it cross the x-axis?
No.
No. All right. So I'm going to ask you this. We know it has a we know that this function has a y-intercept. They all do. So let's find it. To find the y-intercept, you let what?
X equals 0.
X equals 0. All right, so your y-intercept, blank. And it's probably going to tell you to write as an ordered pair. So you're going to say 0 comma something. So if x is 0, what's 0 minus 1?
Negative 1.
What's negative 1 squared?
1.
What's 1 times 2?
2.
What's 2 subtract 8?
Negative 6.
Negative 6. So there's your y-intercept. Okay, now, without graphing it, without doing anything else except just looking at what we have so far, does it have an x-intercept? Does it cross the x-axis?
Yes.
Yes. Why? What did you do to determine that it does cross the x-axis?
Look at where the vertex
Look at where the vertex is. The vertex is in what quadrant?
4.
In fact, do you really need to know what quadrant it's in? You just need to know if it's below the x-axis. Because you know it goes up, right? So 1, negative 8, 1, negative 8 is somewhere around here, correct? And the problem opens up, opens down. If it opened down, would it have x-intercepts? No, but it opens up, so it does what?
Has 2 x-intercepts.
Yeah, it crosses the x-axis twice. So it has x-intercepts. We're going to have to find those. The way it's written, it's not that difficult to find it. But before we find x-intercepts, because it's going to take us a little bit, maybe 2 minutes to do that, I want to ask you this. Where is the function increasing and where is the function decreasing? So f is increasing, blank. F is decreasing, blank. Remember that was on the last test? So remember that interval you give me has to be your x values, and a few of you, most of you were able to get that on the test. There's probably about 3 or 4 that still have issues given a graph determining where it's increasing and decreasing. You have a rough sketch of that graph right here. As I go from left to right, what are these y values doing? Decreasing, and all of a sudden they're doing what? Increasing. But remember, you got to give me the x coordinates. What is the x coordinate right here? 1. So from negative infinity to what? 1, what are your y values doing? Decreasing. Negative infinity to 1. And then from 1 to what? Infinity, what are your y values doing? Increasing. All right? Now let's find the x-intercepts. All right, so here's how you find the x-intercept. We know we have them, right? All right, let's find it. Well, if to find the y-intercept, I let x be what? 0. Think back on the last 2 tests that you had. To find the y-intercept, what did you, I'm sorry, to find the x-intercept, what did you do? Let y equals 0. Well, what represents y in this problem? F of x. So you're going to say 2 times x minus 1 squared minus 8 has to equal what? 0. All right. Okay. On test 2, you could have had that equation. I could have given you that equation, and I could have asked you to solve for x. What would you have used to solve that equation?
Well,
No?
no.
What's the easiest way to solve for x? The square root property.
I get a smile face. I need a smile face.
The square root property. Remember, something squared equal a number, you take what? Square root of both sides.
Just gotta add eight.
But you don't have that something squared by itself yet, right? So you got to do what first? Add 8 to both sides.
Then divide 2.
Yeah. You got to get that x minus 1 squared by itself. So you got to divide both sides by 2. So you get x minus 1 squared equal what? 4. So that's where we're at. That should look familiar.
Square root property.
Then you take the square root of both sides. Remember, you take the square root of both sides. What should you also use?
Plus or minus.
Plus or minus. See, things that you had in the past always comes back at some point. So the square and the square root undo each other, so you get x minus 1 equals two things.
Plus or minus.
A 2 and a what? Negative 2. Right? And you just solve each equation, you're done. Add 1 to both sides. What's one of my x-intercepts? 3. Add 1 to both sides. What's the other x-intercept? Negative 1. So those are your x-intercepts. 3 and what? Negative 1. Let's graph it. Take out a graph paper. All right, so we're going to graph this. Just follow the information. What do you need to graph a parabola?
Vertex.
A vertex. What's a vertex? 1, negative 8. I'm going to go ahead and use this one. All right, 1, negative 8, right? Oops, I'm sorry. 1, negative 8, right here. All right, 1, negative 8. What is the Y-intercept? On my math lab, listen, on my math lab, they're going to ask you to find the vertex. They're also going to ask you to indicate the intercepts. So we found the Y-intercept. What's the Y-intercept? What was it, 0 what? 0, negative 6? Oh, by the way, make sure you put that in parentheses. Because Mark knows all about that. Mark's in his mind, well, you take points away from yourself. What else do you need a graph in order to help you draw this parabola? Axis of symmetry. Now, when you do the axis of symmetry, you're going to draw a dotted line because it's not really part of the graph. You'll notice if you look at parabolas, you just have that parabolic shape. You don't have that axis of symmetry drawn. You draw it to help you draw the graph, and then if you want to, you can erase it, but go ahead and leave it because I want to see it. So the axis of symmetry it goes through the vertex, right? Y'all agree? Okay. Now think about what we talked about yesterday. If this point is on the left of the axis of symmetry, and how many units is it?
1.
Then on the right, you better have what point?
1.
That point right here.
2.
You don't have to tell me what the coordinates are, but that's what you do. Now the x-intercepts. The x-intercepts are 3 and negative 1. Here's 3. Look. Make sure it makes sense. Okay, look. 3. How many units is 3 from the axis of symmetry? 2. If I go 2 units this way, what is it that I found? The negative 1. So if you made a mistake and you found the x-intercepts to be 3 and let's say negative 4, would that be correct? No, because 3 and negative 4 are not symmetrical about the axis of symmetry. So you know you did something right? So you can always, there's always a check and balance here. And guys, you're done. You just do this. Draw a parabola. Do the best you can with drawing this. Just like this. You see how I'm drawing it? Just kind of like little pieces, making it curve though. Look how I'm doing it. And make it look symmetrical, by the way. I kind of messed this up. But don't forget to draw the arrows. Don't forget to draw the arrows. All right, and you're done. That's your graph. That's all you do. All right, let's do one more with the vertex form. Actually, it might be 2 more because let's do 2 more. All right, number 2. Suppose that g of x equals negative 2 times x plus 1 squared plus 4. Yeah, that's fine. Plus 4. Actually, since I'm doing that one, let's do plus 6. Plus 6. Let's do plus 6. All right. You need your calculator with this at some point, though. Make sure you take your calculator out. Okay. What is the vertex?
Negative 1 plus 6.
Negative 1, 6. Y'all agree? Okay. Once you find your vertex, the next question will be the axis of symmetry. Y'all agree? All right. So at this point, this is what I have, because at some point you can be asked to graph this. So I have the vertex, which is negative 1, 6. So that's here. I'm going to draw my axis of symmetry, this dotted line. Now remember, the axis of symmetry always goes through the vertex. Just like that. All right. Then you're probably going to be asked, does it open up or down? It opens down. Why does it open down? Because A is negative. A is a negative 2. Since it's negative, it opens down. So it opens down. So these are all things that can be used to help you draw this graph. All right, so note opens down. All right. Now, what is the domain? So there are going to be some questions that on my math lab that's going to ask you, without graphing, we're going to graph it though. Without graphing, they're going to ask you, what's the range? You don't have to draw the graph first in order to determine the range. All you need to know is where's the vertex and whether it opens up or down. That's all you need. So the vertex we found, what's the vertex?
Negative 1, 6.
Negative 1, 6. Negative 1, 6 is in what quadrant? Third. We know that it opens.
No, it's in the second.
Oh, I'm sorry. Negative 1, 6 in the second. Negative 1, 6 is here, right? So guys, when I when I did this, y'all never said anything.
Just anything like
We had the vertex be negative 1, 6, right? And I went ahead and I plotted this point. Not one of you said anything.
oh, I don't know.
That's right. You got it correct. You get a smiley face too.
I didn't want my smiley face.
I'm gonna draw in your forehand.
That's why I didn't see what you did.
So negative 1, 6, right? Y'all agree? All right, it goes right here. All right, so negative 1, 6. And it goes down, right? Okay. So what's the range?
Negative infinity to 6.
To this y value, that was negative 1, 6. So what's this y value? 6. So the range?
Negative infinity to 6 with a bracket.
With a bracket. All right. And we know that the vertex is a max or min.
Max.
Okay. They all have y-intercepts. To determine the y-intercept, you let
X equals 0.
x equals 0. All right, so let's go do that. If x is 0, what's 0 plus 1?
1.
What's 1 squared?
1.
What's 1 times negative 2?
Negative 2.
What's negative 2 plus 6?
Positive 4.
Positive 4. So my y-intercept equals positive 4, right? If they tell you to rise in ordered pair, you're going to say, so I'm going to have y-intercept blank. You could either say 4 or
0, 4.
0, 4. If it indicates rise in ordered pair, you have to say what? 0, 4. So I'm going to go ahead and plot that, 0, 4. So 0, 4 is here. That's where the graph crosses the y-axis. And right away, I know another point of the graph.
Negative 2, 4.
Right here, right? Okay. Now, I just need 2 more points to plot. And remember, we're using the idea of symmetry here. We know it has x-intercepts. Let's find it. Let's find those x-intercepts.
So 2, 5, 0.
Let y equals 0. So that means this. That means that this expression right here is going to equal what? 0. So negative 2 times x plus 1 squared plus 6 equal 0. When you're dealing with vertex form and you want to find the intercept, the x-intercepts, don't follow this out. You're typically going to make a mistake anyway. Because what some of you are going to do is you're going to distribute the negative 2 and then square that. That's a mistake right there. You got to square first, and then distribute the negative 2, and then add 6, and then you have to factor. And that's not factorable, by the way. You're going to see why. It's not factorable. All right? So, you want to use the square root property because you have something squared. See this right here? You have something squared right here. So if I can get this by itself, then at the end I can do what to both sides? Take the square root of both sides. But first I got to get rid of this 6. So subtract 6. So negative 2 times x plus 1 squared equal a negative 6. And then divide by negative 2. These divide out, so you get x plus 1 squared equal 3. All right, so that's where I'm at. The previous problem was easy because when I took the square root of both sides, 4 was a perfect square, but 3 is not. So you have to approximate. So take your calculator out, and this is what you're going to do. So just like we did in the previous problem, if you look at the previous problem, see right here? I took the square root of both sides, right? So I'm going to take the square root of both sides. Watch. Square root. But what else must I put? Plus and minus. So make sure you compare those. This with this. But here I was able to rewrite this using a whole number, or using an integer, 2 and negative 2. Because the square root of 4 is a perfect square, but 3 is not. But you can still want to write it like this, though. You can write it as 2 separate equations. So you're going to say x plus 1 equals what? Square root 3, and you're going to say x plus 1 equals negative square root 3. And then you're going to tell me what x is approximately equal to. So first of all, you're going to subtract 1, right? So I get x equals negative 1 plus the square root of 3. And over here, when you subtract 1, that's going to be x equals negative 1 minus the square root of 3. So what is your x-intercept approximately equal to?
0.73.
So on your calculator, you're going to do this. You're going to say negative 1. So here's your negative button right here. Negative 1 plus, and then the square root function is that blue part right here, right above the x squared. To get to it, though, I've got to press the second function. So I'm going to say second, and then x squared. You see now, you see that square root? I put what number there? 3, and then close parentheses, and then press equal, and you get, and I think I said round to the nearest tenth on the worksheet, so 0.7. 0.7. Okay? Over here, make sure you know you use a calculator. Negative 1 minus the square root of 3, close, and I get what this time? Negative 2.7. Okay? And if I can tell if I made a mistake when I plot those x-intercepts. They better be symmetrical about the axis of symmetry, correct? So 0.7 is about here. Okay? And then negative 2.7, and just kind of what I would do is watch. You see, here's the axis of symmetry, and here's my x-intercept. So that distance may be the same as what? That distance. So that's about 2.7 right here, negative 2.7. I just used those little distances to help me. And all you do is just graph it now. You're done. Just do the best you're graphing it, though. Make it look like a parabola. Don't do these. Don't draw a line. It's supposed to be a curve that looks like a parabola. Now, I'm going to tell you this. Some of you have a habit of doing this. Watch the pen stroke. There's a couple of you to do this. Does it do that? Does it do that? No. Okay? Some of you did that with exponentials. Some of you did this. Watch. And then all of a sudden it went this. All right, guys. Does something like this, right? All right, and there you're done. That's it. Okay? All right. Okay, now, let's look at this. Watch this. Suppose we have this. All right, guys, here's what we have now. What form is this function in? General form. Is it in vertex form? No, it's not in vertex form. It's a general form. So, we need to find the vertex. The issue is, it's not in that special form that you're familiar with. But there is a vertex formula you can use. All right, there's a vertex formula you can use. So here's the vertex formula. Now there's a derivation for it. With the time we have left, there's no time to derive that formula. So I'm just going to tell you what it is. So here's the vertex formula. All right, so if you have a function ax squared plus bx plus c. So if your quadratic function is written in general form, your vertex is this. Remember, your vertex has an x-coordinate and a what? Y-coordinate. Okay, the x-coordinate is found this way. Negative b divided by 2a. That should look familiar because in that part of the quadratic formula, remember your quadratic formula? Watch, your quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. See this part right here? That is the x-coordinate of your vertex. That's the x-coordinate of your vertex, negative b over 2a. So I'm going to ask you this now. I'm going to ask you this. Suppose I tell you that x is 1, and we'll find the y value, right? X is 1. I want you to find the y value. We're not going to do it, but I want you to look at this notation. So if I wanted you to find the y value, couldn't I say this? Couldn't I say find f of 1? Right? So remember that 1 stands for what value? For what letter? The 1, x. F of 1 is your y. Okay? So I'm bringing this up to kind of explain what this is. So this right here, I want you to notice this. So if let's go ahead and find it. So f of 1 would be 1 squared, which is what? 1 minus 4 times 1, which is 4 plus 1, right? So f of 1 is negative 3 plus 1 is negative 2. Y'all agree?
Yeah.
So remember, this is your x, this is your what? Y. So a point on the graph is going to be 1, negative 2, correct? Do y'all agree that what I'm about to write means the same thing? 1, comma, f of 1. Do they mean the same thing? Are those two the same thing? Yes or no? Yes. Because f of 1 is what? Negative 2. F of 1 is negative 2. So these two things are the same thing. So you see that f of 1? So I'm going to use it here. So this is my x-coordinate. How do I find my y-coordinate? Take this and plug it back into what? X. So you're going to say f of what? See how I said f of 1? Then there's going to be f of what? Negative b over 2a. So that's your vertex formula. So that's what I'm going to give you that formula. You just need to know how to use it. So your vertex formula has an x-coordinate and a what? Y-coordinate. Your x-coordinate, how do you find the x-coordinate? Use what expression? What expression? Negative b over 2a. Once you find negative b over 2a, how do you find the y-coordinate? You substitute this into the function f. That's what this says. All right? So let's see how it's done. Watch how easy this is. Okay, so we're finding the vertex, right? Right? So you're going to say x-coordinate equal. All right, first of all, let's determine what a, b, and c is. What is a? What's b? And what's c? That should look familiar because that's what you use in the quadratic formula. So the x-coordinate is the opposite of b. What's the opposite of b?
4.
Divided by 2 times a. What's a?
1.
So that's 4 divided by 2, which is what?
2.
2. So I found the x-coordinate of my vertex. What's the x-coordinate of my vertex? 2. All I got to do now is find the y-coordinate. Well, how do I find the y-coordinate? I got to find f of what now? 2. 2. So the y-coordinate is going to be f of 2. And so that means you go to your function f, and where you see the variable, what do you plug in? 2. So I get f of 2 would be 2 squared minus 4 times 2 plus 1. What's 2 squared? 4 minus 8 plus 1. So that's a negative 4 plus 1, which is negative 3. So what's your vertex?
2, negative 3.
2, negative 3. Your vertex is 2, negative 3. All right. Now, let's go ahead and now there's a bunch of other things you can do here. You could find the y-intercept, all that other stuff we did. You do the same thing here. But I want to go and just find the vertex of another function first before we go any further with these. So let's find the vertex of this one. Let's say g of x equal negative 3x squared plus 12x minus 4. Negative 3x squared plus 12x minus 4. I'm going to make sure that the vertex, the x and y coordinates are integers. They don't have to always have to be integers. Your vertex could technically be a fraction, like 1/2, comma 3, 2/3, comma 4/5. Okay. But for us, your vertex, the x and y coordinates of your vertex will be integers. All right, so what's a vertex formula? Negative b over 2a, and then f of negative b over 2a. So that's what I'm going to give you. I'm going to give you this. You need to know what that means. So to find the vertex, I'm going to find the x-coordinate first. So the x-coordinate equal, first of all, let's determine what A, B, and C is. A is what?
Negative 3.
B is what?
12.
And C is what?
Negative 4.
In fact, for the x-coordinate, do I need C at all?
No.
No, because I just need B and A. Okay, so the x-coordinate of the vertex says I take the opposite of B. What's the opposite of B?
Negative 12.
Divided by 2 times A, what's A?
Negative 3.
So it's negative 12 divided by negative 6, which is 2. So I found the x-coordinate of my vertex. To find the y-coordinate of my vertex, I find what? F of
F2.
2. That's going to be your y-coordinate. So you go to your function g. Oh, I'm sorry, I said f. I should say what? G. So I find g of 2. Find g of 2. So I'm going to get negative 3 times 2 squared plus 12 times 2 minus 4. 8. To get positive 8, make sure you see, make sure that's what you got. So any questions on finding the vertex using the formula? That's all you do. Everything else that we found in the previous problems, we do the same thing. Okay? All right, so let's go to number 1 again. F of x equal x squared minus 4x plus 1. What's the vertex? 2, negative 3. Found it. What's the axis of symmetry? What is it? x equal 2. So at this point, I'm going to ask you to graph it, but at this point, so far I have 2, negative 3, which is here. Here's my axis of symmetry. Now, in my math lab, here's what they're going to ask you in my math lab. They're going to say, find the vertex, find the intercepts, and then graph. Okay? So then, if all you want to do is graph this, what's the y-intercept? Huh? Nope, nope. To find the y-intercept, you let what? X be 0. Come on, guys, let x be 0. What's your y-intercept? 1. In fact, I want you to think about this. Look at your general form right here. ax squared plus bx plus c. If x is 0, what's the only thing left? C. Your constant is your what? Y-intercept. So if it's a general form, C is your y-intercept. Because if x is 0, this is 0, this is 0, and what's left? C. So over here, this is in general form. What's your constant? 1. So that should be your y-intercept. And it is because what? You let x be 0, right? What's 0 squared? What's 4 times 0? So 0 minus 0 is? 0 plus 1 is 1. So your y-intercept is equal to 1. So I plot the point 1 on the y-axis. And if I know this one, then what else do I know? Do I know another point right away? Yes, the idea of symmetry right here. 2 units, 2 units. But I need for you to give me another pair of points. Now look very carefully. Just to let you know, we're going to talk about this tomorrow. Finding the x-intercepts. First of all, you see it has x-intercepts, right? Because it's going to cross the x-axis. That is not as easy. Do you remember on test 2 and test 1, I think, maybe just test 2, you were asked to solve this equation? What did y'all use to solve this equation? If I had this, if I asked you what's x squared minus 4x plus 1 equals 0, what did you use? What did you use to solve that equation? It's not factorable. Quadratic formula. Quadratic formula. This is not factorable, by the way. So if I'm going to find the x-intercept, I would have to use quadratic formula. So you see how in some of these problems it takes a bit of work? On the final, you don't have that bit of work, so you're not going to be asked to do all this stuff on the final or a test. So we're going to come back to that part tomorrow. But all I want to do now is just for you to give me another point, though. Let x be a number. Let x be what? You want to use 1 or 3, or you want to use negative 1 and 5? It doesn't matter. Just use something close to what you already have. You want to use 3? Okay. If x is 3, I get I need to find f of 3. That's what I'm trying to find, f of 3. So if x is 3, what's 3 squared? Okay. What's 9 minus 12? Negative 3. What's negative 3 plus 1? Negative 2. Use your calculator, David.
Is that negative 12?
I asked you, I said, what's negative?
Negative 13? You said negative 13.
I didn't say negative 13. All right. So remember, it's 3 squared minus 4 times 3 plus 1. So 9 minus 12 is what I asked you, and y'all said negative 3. And then I said, what's negative 3 plus 1? And David said negative 12. Negative 3 plus 1 is what? negative 2. All right, so plot the point 3, negative 2. And so if I know this one, then what else do I know? Right here. And do the best you can with drawing your parabola, and you're done. That's all you do. Okay? You see how easy this is? All right. So we're gonna now remember we're still on part 2. We're gonna continue at part 2 tomorrow. All right. So let me. I think I can give you a worksheet on this though. Let me just check.